And we will also be fixing our Voxel Automata rules to improve them and make it so the water can flow a lot better than it did in the... All right, so even though that system was working and I can place blocks and let water fall, it was super painful and took a long time. And I really did not enjoy that. So even though I might not have shown it, placing blocks really did take a long time. So let's go ahead and fix this and make it a lot easier to place blocks. As well as another issue I came across was just the fact that I couldn't remove blocks. Like I would place a block and then sometimes I might place one by accident and I couldn't remove it, and that just like totally messed it up. So let's go ahead and just fix this. So for this, I'm gonna go to Voxel Target, and let's start by actually going into Unity. And let's completely change the way our indicator works. So instead of our cube being bigger, let's just say 0.5, 0.5, oh, 0.5, and 0.5. All right, and then we can just reset the position. It doesn't really matter. All right, so instead of moving our parent indicator game object, we're now going to create the cube as the indicator. And now let's go ahead and reset that in our script. All right, now let's change the way this works. First, what I'm going to do is we've got our grid position, so this locks it, right? We also need to create, well, what we're going to do is we're going to shoot a ray out from the camera so that we can place blocks, almost Minecraft style, where I can look at a block and then place one right there. And place it on that side of a block. You'll see what I mean. All right, so let's do if physics dot raycast, and what I'm going to do is instead of that, we're going to do the origin. So the origin is going to be the camera dot position, and the direction is going to be the camera dot forward. And then the max distance, let's go ahead and in here we were multiplying by 10, so let's change this to serialize field private float max distance. All right, let's set that equal to 10 as we had before, and then we could just multiply these here. All right, and now in the physics.raycast max distance, and the layer mask, I don't really care about that, so I want to change it to out ray info, out raycast hit, and this isn't working because I need to find a layer mask. I don't want a layer mask. Is there not an override for this? Okay, so out raycast hit. So if I do this, I'm gonna have an infinite max distance. So we'll just use the max distance for the block. Unfortunately, the raycast, I can't seem to get a max distance. Let's see. Oh, there we go. Okay, I just had to change the order of these. Okay, so we got it. All right, so this hit variable that physics.raycast is passing out to us, it's going to contain a hit.point. And we're just going to set our indicator dot position equal to the hit.point. All right. Yeah, okay, and then the indicator position is going to equal the grid position. Let's just override this for a second. And let's click play just to see how this works. And we're ready. And now what you'll see is I can, oh, and it stopped working for some reason. Let me just, why did it stop working? Let's see. Raycast. Oh, else. Let's just do an else here. Grid position is going to equal there. And yeah, all right. So otherwise, we're just going to do our regular put our block or indicator 10 blocks away from us. I don't think... Oh, I think I know what's going on. This has a collider. Yeah, so we're moving this block to wherever the raycast hits it, but the raycast is hitting, the raycast coming out from our camera is hitting the block itself and consistently moving it towards us. So let's just sort of move that. We don't need that. All right. Yeah, and then one other thing I forgot is the fact that our voxels don't have collision, so we can't shoot a ray at them. This will be fairly easy to fix, so just go to scripts, and in voxel renderer, in our renderable, let's add a new component. So private mesh collider, and we'll say mesh collider is going to equal GameObject.add component mesh collider. All right. And then in set mesh, we'll say mesh collider dot shared mesh is going to equal mesh. All right. Yeah, it should be working now. Let's click play now. Hopefully it works. And you'll see it does. So if I get closer, the block still stays. Now let's just make it so that the block snaps to a grid when we are doing raycast. Yeah. All right. Let's go ahead and do that. One other thing, I don't know why, but the indicator is now at scale of 1. I want it to be 0.5. And it's going to create a little cool effect for us when we make it small. It'll look like a little knob on the side of a block once we finish this. All right, voxel target. All right, so grid position. Currently, we're setting the block equal to grid position. So what I want to do is I want to say indicator.position is going to equal our target position. And then I'm going to create a private vector3 target position. And then we're going to set target position equal to the hit.point or target position equal to the grid position. And we can actually just change this to target position equals this, rounded position. Although we are not doing any kind of rounding. So let's go ahead and round this hit.point. So equals a new vector here. We want this to work on a grid too. And we'll say, instead of all this math, we'll say hit.point.x, hit.point.y, and hit.point.z. All right, and with that, it should be fully working on a grid now. Let's click play again. Let's try this. And yep, and you can see it's on the grid, although it's snapping to the corners of blocks. I just realized I need to clarify something. So we need a position here for the grid position of our voxel that we want to add or subtract. So I'm just going to rename this to grid position. And then in here, we'll say grid position dot set. Oh, hold on. So set voxel at this grid position in the world. And then with that, we need to change a couple things. So for now, the indicator position in the else block is going to equal a new vector3 here plus half of a vector. And we're not going to worry about adding blocks in here. We'll only add blocks in here, if that makes sense. Yeah. All right. Yeah, looks good. So we're going to say grid position equals this. And instead of saying get key for space, let's say if we are have the mouse button down, so if mouse button held down, if the mouse button is being held down, the 0 mouse button, so that's the pointer finger mouse button, the left mouse button, it's the primary, click, primary mouse button. And then we also are going to have to handle a case for else if input.get mouse button 1, which is to remove a voxel, right? So what we need to do is our grid position is going to change depending on if we are adding or removing a block. So if I have a block and I'm clicking on it, I need to go inside that block, so I need to use the negative normal, right? So the grid position would equal hit dot point minus half, and I can actually get rid of this here and just say hit dot point minus half of the hit dot normal. Half of the hit dot normal, so half of the hit dot normal. Right, and that moves us into the block. Move into the block. And that's if we're wanting to remove the block. So we're gonna say this is the secondary mouse button. We're gonna use the right click for removing and left click for adding. All right, so store.setVoxel equal to the grid position here. And we don't really need the variable anymore, I guess, since we're just using it locally. So let's change this to, then we can get rid of that. And let's say vector, we don't even need this. Vector 3 grid position for that. And if we're adding a block, it's vector 3 plus half the normal. So set voxel at plus half the normal. All right. So let's try this now. If raycast hits and we are clicking a mouse button, although we don't need the cube to follow us around. Let's just test this out. If we're successful, we'll be adding blocks. If we're not, then blocks will not be appearing. So let's just click, and yeah, 2 blocks appeared. Click, and it seems like our mouse click is true as long as I'm holding it down. So if I hold it down, it's just going to add blocks until it gets to me. So let's change this. So you have to actually like click continuously. So get mouse button down. You can only click it once. It's on the first second that you click it. And now let's try this. Let's try this. Place a block. Yep. All right. So we've got blocks placing. Now let's get the indicator to work. Well, I settled on the very simple solution of just setting it equal to the hit dot point plus the normal divided by 2, which looks like this. And it's not a rounded position just because rounding the position would actually be not very simple because of some complicated math things that I don't feel like explaining. All right. The other thing that's a little annoying is the maximum distance is just not far enough. So we're going to change that to default to 20, and then go ahead and just change that in the inspector in the player. Change that to 20 as well. All right. So with those changes, our editor is now working. The only thing we haven't tested is removing blocks. So let's go ahead and do that really quick. I have adding blocks, but removing blocks is not working. So let's go ahead and just add a block and right click, and it doesn't remove. Unfortunately, it does not. So let's see why. Oh, that's right. So when I set voxel, I'm setting it to rock again. So I just need to set that to 0 for air. And let's try that again. Let's see. Oh, well, it works because I just removed a block. All right, cool. And then I can remove blocks. All right, so before we get to making a fancy waterfall, like I did earlier, I realized you may have noticed that the water wasn't flowing down the canal I made. It was like flooding out. And I really did not like that. And then I realized it's because I actually made a mistake in our Voxel Automata script. So let's go ahead and fix that now. And once we fix this, our water should flow a lot faster and a lot better and not overflood in certain areas. All right, so here, we get a direction randomly from our palette dot directions, but our mistake is in that we only check if one of those directions will work, and if it doesn't, then we set it. But maybe a different direction would have worked, and we just never tried it. So to fix this, let's create a list of int3, and that is an int3. Yeah, okay, int3, call it possible directions. Yeah, and let's create it as a new list of possible directions. All right, now, our possible directions, not impossible, because there is some directions we can't move in because there might be rock there. So what we're going to do is if get voxel, if get voxel at direction.x, and actually what I realized here is we're going to say a for int I equals 0, I is less than directions dot length and I plus plus. And now we're going to go through each direction in our directions here and add it to our possible directions if it's possible. So what that's going to look like is if palette.directions I, and we're going to say get voxel. So get voxel directions I plus a new int3 of x, y, z. And I don't think get voxel works with int3s. No, it does not. That's going to make this code pretty ugly. So I'm just going to change this to get voxel. I'm going to change this to an int3 index. And there we go. Now we have a different way of accessing this, which will make it easier. All right. And there. Oh. Index z. All right, now in get voxel, if the voxel at that position and our voxels. All right. If get voxel is equal to air, and I apologize, if it's not equal to air, then we will say, or no, if it is equal to air. If it is equal to air, that means we can move there. So possible directions dot add, and we'll say palette that directions I. Right? And yeah, so this loop is basically adding a direction if it's possible. So add direction if possible. And then in here, we're going to change this direction to get a random direction from our possible directions. So we're going to say possible directions and unity engine.random.range possible directions dot count. And we're only going to do this if there was a possible direction. So possible directions dot count is greater than 0. Then we will do this. And since we know that direction is possible, we no longer have to check for air. And there we go. Now we will check and try all possible directions first to see if they are possible. And then we'll pick one from the possible directions. So our likelihood of actually, getting a possible direction is much higher. Whereas before, what we were doing is grabbing a random direction. Oh, let's see. Is that direction possible? Oh, oh well. And here we're saying, let's make a list of the actually possible directions, and then let's pick one from there. Yeah, so let's go ahead and change this function to do the same. I'm just going to kind of copy what I did over there here. I'm going to say add to the list of possible directions. Now, it's very important that we change it to secondary directions. And here, secondary directions, and secondary directions. Because otherwise, we're going to be using the wrong one. All right, now let's do if possible directions dot count is greater than 0. Do this. And we can remove that if statement since we know it's possible. And let's see. All right, so as I was experimenting, for some reason, water is somehow water is erasing dirt. So I'm gonna figure that out and then I'll get back to you guys. Instead of using possible directions in here like this, I just went ahead and used the original one. So we're doing all this work to get the possible directions for nothing. So just go ahead and change this to possible directions and this to possible directions dot count. And now if we click play, all right guys, and we are back. I made a little waterway, and now if I click the Y key, and you can just see water flowing. Isn't that awesome? And it's actually flowing. It's not flooding out of the side. It's properly flowing down our waterway. All right. So now that we've got building working, I just want to change something. I want to change it so that our indicator, our transform indicator, whenever we do not hit it with a raycast, let's just say indicator.gameObject.setActive false. So let's just hide the game object basically. And then in here, if we do hit array, let's just say set active to true. Yeah, so now if you're not hitting anything, you won't see this block straight in front of your face. Let's try this. And yeah, it goes away and then it appears. And when you're wanting to add, it comes back. Because we can't, right now, even in the code, it won't let us add if we are not facing a block. All right, so yeah, I think that's it for this video, but I hope you guys enjoyed it, and I'll see you in the next one.